We're going to add it right in for animal, and now let's go back to our main and try and create an object of type animal. And what happens?
Francis cannot instantiate the type animal.
Animals abstract cannot be instantiated.
Yeah. So that's our introduction. For an abstract class cannot be instantiated, which means you cannot create an object of type animal because it is abstract in nature. So basically, we can't do this. However, you can try the other ones below. You can create objects of type dog, type husky, as they are not abstract classes. Okay? They may inherit from an abstract class, but they are not abstract themselves. Okay? You can create many dogs that do exist, this abstract concept of existence. So, really quick, we're going to go into a little interesting part of what abstract classes do in their value. So, this goes back into inheritance as well, via how abstract works. Abstract is how you basically can enforce a concept or something on its subclasses when you declare something abstract. So that may sound like a bunch of weird words. So let's, if we said, let's agree on how animals breathe, okay? So I'm going to create a method. And I'm going to say follow this exactly and leave it just like this and see what it says. Comparison's good? All right. Now, right in here, we're going to put the keyword abstract.
After public?
Yeah. Public abstract void breathe.
Identifier special.
Public abstract void breathe.
And yeah.
You should have with these as well. You should so the error. Well, you should get an error that says abstract methods cannot have a body or something around that. Abstract method. So what happens with an abstract method? So an abstract method is kind of like an abstract class a little bit, in that when I define something as abstract, I say that it's not a concept I can use. Okay. So if you put abstract right here and have any code that happens here at all, or even just no code, if you have the abstract, it'll give you a compiler error and say you can't do that. Abstract methods cannot have any code with them. So the way to fix this, you delete every what comes up all of these, your braces basically, and then what you do is you add a semicolon at the end of the method, which you don't do normally. Remember, normally you just have your braces. So now that we have our abstract class, really quick, we can jump back to the main. If you want to see this error pop up, I'm going to say it might pop up automatically. Jump over to the dog or husky class, and it should now give you a compiler error on both dog and husky. Yes.
That dog is not abstract, it cannot override the abstract method.
Dog is abstract and cannot override abstract methods. That is wrong. I don't know what that means, but that's definitely wrong. And so, public. Did you make all classes abstract?
No.
You just made animal.
Yeah.
So
Where are we supposed to do dog instead of animal?
yes,
Yeah.
yeah. So what happens is right here we have this abstract breathe. We declare it as abstract. Once you make something abstract, anything that inherits from it is now required to have it implemented. So the important thing to remember about is our onion diagram. Again, one more time. So we go up and look for the first implementation when we're finding something. So I'm just going to start with the dog one. We've got dog and we've got animal. So I have some method called breathe. It exists already. So if I go to try and look for it, I'll look for it in dog and then I'll look for it in animal. And when I run into it in animal, there's no implementation because it's abstract. So the requirement for it is that I have to define breathe in any class that inherits from this. So any abstract methods must be defined in any abstract methods must be defined in any subclass. So in our example, we're going to define it in dog really quick. So in our dog class, jump over here. So in our dog now, we have to define it. Our requirement for defining an abstract method is we provide the exact same name, and we can then continue. Public. Oh, and sorry, without the abstract keyword. I can't read that. It's not gonna work. Can't read that. All right. So now, if you jump back over to Husky, Husky will not complain anymore. So Husky won't complain. It used to complain because it said there was no implementation of the abstract method because we defined it in dog. So in our Husky one, we said there's an abstract breathe here. We defined it here. So it'll find the implementation of it before it finds the abstract name. Okay? So now that we've implemented it, once we're just gonna get it to print out some information. We're just gonna say I breathe. You can add a woof to it too if you want, I guess, or a bark. Don't know. So, is there any questions on this like abstract so far? Are we good so far then?
Mhm.
So I'm gonna bring up a really quick different example. So this one doesn't. This is more good. This one was for inheritance. This was really good for abstract. It's a little bit weird to make an abstract method for animal that's run in dog and used in husky. So a better example would be if you're talking about like shapes, for example. So let's say I have a public class shapes. So this class exists, and there are calculations I want to be able to do on shapes. And for example, I would like a class called area. Okay? So one thing I could do is I could create this class area. I could say, I want to do some kind of calculation for the area, but then what do I pick? What's the default way to calculate area for any shape? Because there's a lot of different types of shapes, and it's very dependent. Now, what is it? If we're talking about trapezoids, squares, circles, it gets a little hard to say that. So the better way to define your classes is to give it this abstract keyword right here. Make area an abstract method. And then when you implement, for example, square, if you have a class called square, you implement area in square, as length times width. In circle, you can do, so get this math.pi times r pi r squared. So basically, instead of trying to give some default implementation and then overriding it in every single class, we define that you can compute the area of every shape, but we should define each one per class. So this is a good example of a great time to use an abstract class. For basically for doing shapes. You can do perimeters as well. That could be another abstract method. But are we kind of getting this kind of what abstract is a little bit more now?
I still don't get why we need it. I know it's read it like 3 times already, but I don't get why we can't.
Like override.
We're not using it.
So it helps with. So when you write, basically from before, you know how we overrode methods? That's with polymorphism. So that causes like dynamic binding, which is a runtime thing. This gives us a compile time. So basically, if you run your code and you have 100 overrides, override, it takes a long time to figure out what exactly it's supposed to be doing. This says at compile time, this is what you should be doing. You need this all to have this implemented. And so it's really great for when things share a concept, but are very different in their execution.
Okay.
So that's why I use shapes as a good example, because we talk about shapes. There's a lot of shapes. They're all useful, area is a thing we talk about shapes. Like a triangle, for example, 1/2 base height. But a circle, it doesn't even have a base or a height as a variable. It has a radius. So that we couldn't implement area because it's very dependent on what's there. So we leave it as an abstract method to use to have each class implement, because we know we can do area calculation. We want to be able to compute the area of any shape. We want to require that they have this. This will come into play, abstract classes, as well as we're going to see interfaces come into play next chapter, I believe. We're going to jump into that. I'm not 100% sure. Yes, I believe so. I think we're getting there. Okay, so really quick, some quick rules on abstract. You cannot have an abstract method in a class that is not abstract. Okay? if there is any method that has the keyword abstract in it, you will get a compiler error. It will say you cannot have an abstract method in a non-abstract class. You can have an abstract class with no abstract methods in it as well. That would be a little weird though. You could though, it'll let you. So those are two really quick rules, just so when you try to write code, you don't run into like any weird problems with abstract. So now we're going to move on to one of the other great parts of Java, which is the interface. And it goes very hand in hand with kind of how abstract classes work. So an interface we use is basically a collection of things we want other classes to implement, but it requires that they be a certain way, basically. We basically give them some rules for how they do this. For abstract, we require that you do it. You do exactly like this. You have to do it 100%. And the other option was overriding, which is you have to give it the same name and implementation, and you kind of but besides that, they can pick and choose. So, an interface, it exists in its own file, just like an abstract class. For example, I'm going to take out our animal for now. We have, for example, let's talk about things that fly. So we would say it's a public interface. And we can call it flying object. Alright, so what we do is, it's very similar in for how you define a method in it. The same thing occurs again. Let's give it a void fly. So the implementation is exactly the same. You don't provide a method for it. You provide a name. So make sure I'm not missing anything. I am not. Okay, so interfaces, I do need to add one thing. So before we always had this public-private. Now when we define an interface, there's two things that happen to every method inside. It requires that every method inside be public and every method inside be abstract. These keywords do not need to be written explicitly, but they're there basically hidden, okay? So this is always public abstract void fly. Public abstract void, something else about flying, or is currently flying, for example. So that's how these would work. This is a little bit more for defining some rules that things need to follow, more than the abstract class. The abstract class is more for instantiating things below and requiring that they have very specific rules. This just defines, again, a kind of framework for what you should be doing. It's a lot more useful, in my opinion, of course. So we're going to jump into the first of the very important classes and interfaces that you need to know for the AP test. And the first one is this one called comparable. So, it extends Java.language, I guess. use the raw one. Oh, okay. Don't have to add that. So this is one of the first ones. It's the definition, I believe, in the Java source code looks like this. Does anyone have any idea, reading the name, what it might mean or do? Compares things. Yes. So, as we said before, an interface defines some kind of rules that classes that implemented should follow. So, the comparable interface defines any object that can be compared to any similar object of that type. For example, two integer values can be compared. If you would like to do that, they can implement comparable. Integers are kind of a primitive type, though. How can we compare two dogs to see if they're the same? But we could do that, right? We can agree. So it requires that we have a method implemented called compare2. It's a very, very important method that you will see a lot. Compare2 is an implementation coming from the Java object class, which remember all objects you create inherit from. So this is a method that comes with every object no matter what. So comparable says I require that you implement this method, do something, and it requires that you compare one thing to another. Okay? So really quick, when we use comparable. So let's talk about. We can go back to animal. So public class animal. So when we use an interface, it's very similar. So the abstract class had that keyword abstract and didn't change anything. An interface requires a new keyword, and that keyword is implements. It comes right here. And we're going to implement comparable. Yeah. So this is our class again, our animal class. We're going to have this part right here. When you would like to use an interface, you use the keyword implements, and then you name your interface. Once you do that, it's just the same as when you inherit from an abstract class. It's going to carry some requirements that you implement in your class. So, for example, if we had that abstract, we made our animal class abstract. We're going to delete that keyword in a moment. But we implemented comparable. And sorry. It was an abstract class, and we defined a method called breathe, and it said in any subclass you must define breathe. So, an interface is very similar. It's a little bit more powerful. Our interface comparable has a method defined called compare2. So when we implement our interface comparable, it's going to say you must define compare2. Are you good? Yeah. Okay. So So I'm going to show it like right up on the TV, but we're basically just deleting that abstract keyword. We're going to implement comparable. Okay. All right, so if you don't do anything right now, you leave it like this, you'll get the compiler errors, don't have an implemented compared to, and therefore it says you can't continue. Do not pass go. Before I do that really quick, you can extend a class and also implement an interface at the same time. So the requirement for extending classes is you can only extend from one at a time. Okay? Multiple classes can extend from one parent, but you cannot extend multiple classes. So the way that works is we have animal. Let's say we have dog. You can have fish. This is multiple classes inheriting from one superclass. What you cannot do is have animal and person, and they both inherit, and then we have a class human, inherits from both, okay? So this is okay. Multiple classes can extend one superclass. One subclass cannot inherit from multiple superclasses. Okay? Again, this is a couple of like really quick compiler things that I don't think they ever really have many AP questions on. I know there's one I'm about to describe. I was on my AP test. So I'm going to answer that one now. Okay, so now so this is for inheriting with the extends keyword, really quick. So remember, interfaces are like a set of rules, okay? An interface, but you can apply multiple sets of rules to any one class, okay? So by that reasoning, I can extend multiple interfaces all at once. So let's say I have a very complicated class. It extends from animal. It needs to implement comparable. You know, it has all this stuff. I need to have to do all at once. Here's what the whole thing would look like. It had public class animal. The first keyword that comes first is extends. This is what it'll be inheriting from. I'll make this something else. I'll make this dog for now. Dog. It extends from animal. And it can implement comparable. You can make another one called existence. Breathing, etc. So, the formatting for a very, very complicated class like this is public. You don't really probably want to be using abstract here, but public, class, dog, extends, animal, implements, comparable, like interface 1, comma, interface 2, comma, interface 3, so on, and so forth. So that's what happens if you have all of them all at once. The extends takes precedence over implements because extends will always only have one thing it can extend from. This is a good way to remember. My AP test had this question. Can you implement multiple interfaces? You very much can. The Java language does all the time, actually. There are a couple of interfaces like comparable that do this, that Java uses, so you actually in the source code will see them extend for multiple interfaces. All right. So back to our comparable. Are we good on this really quick? This kind of large string of text. Good. I'm just erasing. Okay. So we're going to go back to back to this. So right now, animal complains. It says you haven't implemented compared to. I'm angry. So next thing you know is what is compared to? Which is a good question because it says create it. Define it for me. So here's what it looks like. It has this method. It returns an int. It's called compare to. And it takes in as a parameter object. So here's what it looks like. So, like I said before, remember any class you create. So here's the class animal. It extends from this class called object. Even if you don't say so, okay? So here's animal. So there's no extends, but remember it does this automatically, okay? So object has a couple methods in it already. But the reason why comparable takes in type object is that so any object created by you can implement comparable and be able to do a comparison, okay? So when we compare objects, the weird question you may say is why is it an integer? If it's like, I'm going to compare two things, and I'm going to give you back a number. Why would it give me back a number specifically? Why wouldn't it give me back just true or false? These are, I can compare one against the other. Yes. Why is it an int and not some just true false? Any ideas? So I will give you here. So let's do some comparing on some numbers, okay? So here's the value to compare to, which is, let's say I have the numbers 2, 8, and 13. So if I compare 2 to 8, it'll just tell me they're not the same. If I compare 8 to 13, it'll say they're not the same. That's great if they're not the same, but what's more useful is knowing something about the actual quantity. So compare to returns an integer value, and that gives us some kind of ordering. So I'm using the number line for this example because this is how you can see what the value will be. So if I were to call compare to, and I compare 2 to 8, it will tell me that the number I passed in is some positive integer value. Okay? It'll return a positive value. It may be 13, it may be 268. It's some positive value greater than 0. If I compare 13 against 8, it will return a negative value. Okay? Some value less than 0. If I compare 8 against 8, it will return 0 exactly. Okay? So I'm going to let you guys test this really quick. We're going to implement our compare to. So just to make this a little bit easy, we're going to give it an integer value. We're just going to call it number. We're going to have a constructor below it. I'll just end it here. Generally, it's best programming practice to have your constructors at the top and your implemented compare to below it. However, I'm writing on the whiteboard, and I didn't think this through super well, that I needed my constructor. So, public animal, we're going to call it int a. We're going to define our constructor. We're going to define our constructor to basically take an integer value and then set it equal to none. Okay, so we're going to create a couple animals and we're going to see what happens with compare to, but we have to implement it first. So far, all we did was type the name down. So we're going to do what's called a cast, and then we're going to check it out, what it does. So the first thing is we're going to compare something of type object to something of type animal, and that's not super useful. So what we're going to do is we're going to cast it. Basically, I like to use that. I'll make an animal called that. Equals, I want to specify that what I want in an animal. And then obj. We'll talk about when we talked about from before, when we said down, what it's called, downcasting. This is related to it. This is just a normal cast. But I would highly recommend doing this for our animal that. So what we want to do right here is, remember, we need to return some integer value. The nice thing to know is that the animal that has this integer number. So we're just going to compare the numbers in a couple different ways. I'm going to run out of space again. Keep your constructor, please, as I'm going to give you the implementation. So let's compare the numbers. So let's say, what if the thing we're comparing it against, what if its number is bigger? What if that dot num is greater than this dot num? So the important thing to remember is compare to is a relative comparison. Okay? It's very important to think about what you're comparing when you start to what you're comparing at the end. comparable in Java all operates the same way. It operates on the assumption that whatever you start at is your 0 point on your number line, and things that have a greater weight give a positive value. So for example, if we talk about our number 8, and we call compare to on 13, this needs to return a positive value. Okay? Because I said I'm calling compare to, I'm at 8. What I want to compare to is 13. 13 is greater than 8. So that's why it gives a positive number. Okay, that's why our compare to, this will give us some positive number. If I did the same thing to 4, I said 8, I want to call compare to on 4. 4 is smaller than 8, so we do have an ordering, and we can say that 4 is less than 8. Okay? So it returns a negative value. So most people like to overly complicate their compare to method. I would highly recommend returning 1, -1, and 0 as your 3 cases, just to keep any unnecessary problems out. So right now we say, is the number we're comparing it to bigger than our current number? If that is so, we can just return 1. We're going to add another second statement. We're going to say, what if that dot number, is less than this dot number? We'll return -1. And finally, if one is not greater than the other and one's not smaller than the other, the only thing left is that they must be equal, so we can return 0.
We don't need any brackets. Right?
Oh, yeah. Yes. Okay, I will explain that. So, this is a little bit of shorthand. I'm sorry.
Did you
Yes.
say return 0 or else return 0?
What? Wait. What now? Really quick.
Do you have to say else return 0 or just return 0?
If it passes these 2 cases, I know it'll get to here. So you can put else if you'd like. It's fine. It'll always hit this case if these aren't true. So that's why I don't.
Wait, so for this dot num, wait, what is this dot num?
So this dot num, this refers to the local scope. So we're in some class animal. Again, we're going to run through this, the actual code of what happens when we create a couple objects. But this dot num is the current one we're talking about. That dot num is what we're comparing it against. So in our example with 8 and 13, this dot num is 8, that dot num is 13.
So this dot num is the num one?
Yeah, it's referring to the number, the object's number that we're passing in.
Okay.
And this dot number is
I have a
the
question
number
for
in
animal that.
Yes.
Is that creating the object?
This?
That? Yeah, animal that.
Yeah, we're passing. I'm keeping this as a line here just to help you out, just to make it less confusing. This
why
line.
isn't there like a new and then something
Where?
for the object like animal that? Why isn't there like a new animal?
Because we passed in an object.
Oh.
The requirement is that it takes in an object, something of type object. You can actually specify here, technically, if you'd like. Remember we said, because remember everything inherits from object. So if it wants an object where a superclass is expected, a subclass is accepted. We can actually pass in an object right here. So if you would like, if you don't want this single line of code, this is fine too. We can just do this. If it would help you guys, that's fine. You can also just do this. That works too. It's just slightly less official. And you may get a compiler error, or you may get a runtime error when calling the method. But if you're the one always writing the code to call it, you are less prone to that happening, obviously. So,
What's with the brackets again?
okay, yes, brackets. So, for if statements, there's a little cheat code in Java. Why do you have to add brackets if it's only one line of code, basically? The answer is that's kind of a waste of code. So, if there's only one line of code, you can do it without brackets. Or sorry, it's actually braces. So you can have braces as well. It's fine. Some people even just do this, just to prevent unintended problems. Both are fine. I was just using it to save space. I'm sorry, I forgot that was a sneak. Something I do sometimes. Okay, so we have a compare to. It's now implemented. We make some comparisons. So really quick, we're going to go create some animals and see what happens. So we're going to jump back into our main. Come over here. and we're going to check out this code, how it runs, and we're going to use it. So we're going to create 3 animals. We're going to use the numbers that we do here. Let's create one with the number 8. I'm going to name these differently, actually, just so they're a little bit better. We're going to call this fish. We're going to call this lion. We're going to give it 100. And we're going to call this next one bacteria. Why not? Okay. 3 animals, like so. So, basically, what we're going to do is we're going to try calling compare to on them and see what happens. So, let's say we want to figure out let's figure out the biggest animal, okay? So usually from before, what we'd have to do is we'd have to go check out number, but number is private. So as a method outside of it, we cannot access it. We can access a compare to, okay? So without giving any information about the animal, I can at least see if one's bigger than the other, okay? So in my example, number is actually more of a weight, kind of like a weight category for this. We don't have to change the name of it, but I want to figure out the heaviest weighted animal. So obviously you could eyeball it. You don't always get the ability to eyeball all your code. So really quick, we're going to say we're going to do some if checks. So if fish dot compare to lion is greater than 0. So, what is this line of code going to do? Really quick. What is it? What am I trying to do right here? What am I asking for? Fish dot compare to lion is greater than 0. Yes.
It's going to compare fish's number, lion's number, also to print out 1.
Yeah, so I'm going to compare fish to lion. So what's going to happen is I'm going to call fish.compare to lion. I'm going to jump over here. So remember, we're in the context of fish. So this fish's number is 1. No, it's 8. Fish's number is 8. We're comparing it to lion with a number of that. So we're going to run through here. We're going to say, is that dot number greater than this dot number? Sorry, I can move. We say if that dot number is greater than this dot number. Remember that dot number was what we passed in, which is the lion. We're comparing it against fish. So this dot number is fish is 8. That dot number is the lion's number, which is 100. So we're going to return 1. So what I'm asking for here is if fish compared to lion, is this a true statement? And is the fish bigger than, or is the lion bigger than the fish? Is what I'm asking for. Is this if statement, okay? So we can print out some code here. Fish bigger than lion. All right, wait. Fish smaller. Right? So the rule of thumb for creating these, because you're gonna there's definitely AP questions on using compare to. So compare to the rule of thumb is whatever you pass in here is what you're comparing against. Looking for things greater than 0 means what I pass in bigger than what I started with. If you want equal 0, if it's equal to 0, it means are these the same? If you compare and say it's less than 0, you're saying is what I pass in smaller than what I started with. Okay? So you can really quickly run this code. I think if you haven't already or tried to, you will see. I'm going to really quickly steal. Get some. You should always define compared to as public, by the way, just in case. It might complain. I just realized for a different reason. You should always define interface methods as public as well. So really quick, I'll do this one. Oh. So, I don't know if on older versions of Java this did work. On my version of Java 9, it does not work. So I'm going to fix that. It requires the exact method implementation. So you have to do the typecast. It requires the signature to be exactly the same. So, that's okay. The number one biggest mistake, which obviously we just made, is if you don't define this method exactly the same as the interface, it will think it's its own method. When you compare something with compare to, or when Java uses compare to, so for example, Java can sort things on its own. Okay? For it to sort something, it must implement comparable for it to sort something for you. If you implement compare to, but if you try to make the method compare to and don't define it exactly the way it's looking, it will sort the information differently. Okay? So just a warning. It's super important to do public int compare to object obj. You can name it whatever you want actually. Just the fact that you have to pass in something of type object. You could name this Steve and it wouldn't matter, but you have to pass in a singular object, not a type animal, specifically for this one. because it's an interface. So really quick, comparing animals. All right, so let's compare to animal. Fish. Did I spell compare to wrong? I did not. So, I did fish right line. Cool. Okay. Let that run. Oh. Oh, I didn't. Oh. Wait, wrong screen. Get a what's this computer? Seems we made a mistake. Did I make a mistake? Oh, I did it backwards. There we go. Okay, sorry about that. I made a little dumb mistake. Bam. Okay. So this is implementing comparable. It's a popular one. Basically, if you want Java to be able to compare whatever you create against something of the same type, you implement comparable. It requires you implement compared to. Done. Okay. So when now you've seen both. Which one you prefer is up to you. I will really quickly read out the exact textbook reasons to pick between the two, as I do not want to mess this up. So, for an interface versus an abstract class is specific but incomplete without subclasses. An interface is when methods are suitable but are applicable for a variety of different types. So an abstract class means everything is related by some group that you inherit from it each time. So for example, an object like animal, inheriting from making animal abstract and having abstract methods in it like breathing is where everything inherits from animal and they all need that specific method. The interface is when there's a lot of different types of things that aren't necessarily related at all, other than you just need them to be able to be compared. Okay? So it's basically an abstract concept. An interface is an abstract concept you want to apply to a variety of things. An abstract class is where everything is related to it by some superclass that you want, and therefore should be related in that sense. So all animals do breathe, but what are comparable objects? That's not really something that is real. So the other value of an abstract class is an abstract class doesn't necessarily have to have all abstract methods. abstract classes can have methods that are already defined. So I could make animal abstract. I could make breathing, or I could make walking, an abstract method and say you must define this on your own. But I could make, maybe changing the number of itself, because it'll have a number for an age, maybe, for example. Changing its number doesn't have to be an abstract method. I know it's always going to exist. I'm always going to be able to change it. So an interface doesn't have any way of. An interface requires basically that you have to implement. You can't implement any method. It has to get the semicolon at the very end. So, and with that note, an interface can't contain variables. It can only contain a set of methods that you require to follow. An abstract class, again, is mostly basically a class. You can have private variables inside of it. So, and I also did mention this. You cannot create an object that's from an interface. Okay. So, it's obviously not even called a class. A class is there than an interface, but you can't create an object like an interface. So,
would you be able to write the book definition on the board?
Yeah, I can write this. This is kind of one of those more caveat ones. That's you should probably just know this one. And I don't want to give it to you in any way that's not exact this way, because I know the AP test asks questions that are directly from this reasoning. Okay. I will write. I'll write the couple of them. Okay, so an abstract class can have non-abstract methods. Or sorry, I'll use the word defined methods. I'll use implemented in the correct one. All right, your face is twice. Okay, so implement methods, only definitions, can have private variables. Size cosmos. That covers pretty much it for the actual important part. So really quick to read them off. An abstract class can have implemented methods, while the interface cannot. An abstract class can also have private variables, where the interface cannot. An interface can have what's called defined constants, but that's like having a defined constant like pi, basically. It's not very helpful as a variable. It's just a constant. And then you cannot create objects from either the abstract class or the interface. And then again, using them is fairly personal preference. I almost never use abstract classes, and I very commonly use interfaces. I think they're more useful, personally. but that's just me. I don't like the abstract keyword, I guess. All right, we're really quickly going to go through a couple of the multiple choice questions because these are going to be the questions where a lot of people miss them, so you should pick up some free points here. For those of you following along with me, it's 148 multiple choice or page 148 multiple choice questions on inheritance and polymorphism. So we are going to run through this. So we have a bank account. There's a savings account and a checking account. We have a bank account and we have savings account. Checking account. Okay, so I'm just going to give the parts of the question that are relevant each time. Are we good on this interface abstract? Good? Okay. All right, so there's a constructor and bank account. It has a couple of methods in it as well. It has two of these. This is the bank account class. I'm not going to write the name really quick. So it's got a bank account double my balance. It's got a deposit one. I'm not going to do all of these. It's got a withdraw. And then it has a get balance. Savings account has, again, two constructors. And a savings account with a double balance and a rate, which again, I'm not super interested in at the moment. Then we have an add interest. Then finally we have checking account. It has just a checking account. Balance. And a withdraw method. Okay. Of the methods shown, how many different non-constructor methods can be invoked by savings account? So it's multiple choice. There's 1, 2, 3, 4, and 5. Here is all the methods. We're talking about savings account. How many non-constructor methods can be called? Anyone? non-constructor methods called by savings account. Multiple choice guess? Anyone? Guesses? Even if you're not sure? No idea? No one has any idea? Not sure at all? 1, 2, 3, 4, 5 methods. Non-constructor, so no, the methods can't be constructors. Anyone? 1, 2, 3, 4, 5? Raise your hands for one method, maybe? How about 2 methods? 3, 4. Okay, so it's 1, 3, 1, 4, and 5. 5 methods? Not sure. Okay, so basically, anything with the name bank account or savings account or checking account as its name is a constructor, so we can ignore that. We're talking about savings account and it inherits from bank account. So it can call all of the methods from itself and anything that is its superclass. So it can call, for one, in savings account, it can call add interest. Then it can call any method from its superclass. So it can call deposit, withdraw, and get balance. 2, 3, 4. So it can call 4 methods. So I'm gonna keep these up here in case I need them. Okay, so we have in a default constructor, which of these correctly implements the default constructor for savings account? Remember, savings account extends from bank account. There's one. This just says my interest rate equals 0. I should probably add that. Sorry. So we have the double my interest rate equals 0. Then we call super. The other one is super, then calls my interest rate equals 0. And then one just calls super. So, we have these 3. Which of the following correctly implements the default constructor of savings account? So what's the correct way to create the constructor for savings account? We have my interest rate equals 0, then call super. We have calling super first, and then doing my interest rate equals 0, or just calling super altogether. Which of these are okay, will not give us any error?
So 2 and 3.
2 and 3? Okay, anyone else? 2 and 3? 2 and 3? Yep, we're good. So you don't want to call super beforehand. As a really good rule of thumb, super should, if you're including it, should only and always be the first line of code in your constructor if you need it. So I'm pretty sure it'll throw an error if you do this. If you try to call super outside the very first line of code executed. Yep. Let me just make sure. Yeah, super must be the first line of the unit it's meant to be. Cool. Okay. So what is the correct implementation of the constructor with parameters in the savings account class? So we have over here this one, the savings account class that takes in constructor. For the record, rate is also in double. I just use the comma to shorthand it. So, which is probably not good. You shouldn't do that. Our options are we have my balance equals balance. Then we have my interest rates equals rate. We have get balance equals balance. Sorry, this is our method call. Then we have my interest rate equals rate. Finally, this next one is super. We make it called the super. Then we say my interest rate equals rate. And finally, we call super balance and then my interest rate equals rate. Oh, sorry, I missed one more. And there's a super balance rate. Okay, so there's 5 of these. 1, 2, 3, 4, and 5. All right, so which is the correct implementation of the constructor? A, B, C, D, E. Yes. This is for the implementation for the one with parameters for savings account. So we're implementing this constructor. The constructor with parameters. Anyone? A, B, C, D, E? Anyone that you see is wrong? You can cross them out. Yes. D is wrong. Why? What?
Wait, do you need a super?
You do not need a super. Anyone?
These classes are public or private?
They're all public classes. Variables inside are all private.
If you don't need a super, then C, D, and E is wrong, right?
You don't need a super. You can have one.
Wait, is E wrong?
E wrong. Why?
It's like for where the superclass, like it can't hold two.
Yeah. Perfect. Okay. So E's wrong. You got that one out. The reason why we call super balance and rate, because we're in the savings account, our super class is the bank account. Bank account does not contain a constructor that takes in two doubles. It has a constructor for one and a constructor for none. Therefore, this would be there'd be no matching constructor, so we'd get an error here. Okay, we're down to 4. Any else? Possible right answer, possible wrong answer. What does or doesn't work and why? Yes.
C has to be wrong because the super will invoke the default. So it invokes 0.
Yeah, so we'll get a default constructor for my balance, and then we'll assign the interest rate. If I had to make a guess, so our parameter over here is balance and rate. If we call the default super constructor, we never assign balance to any value. So what we do is we take a constructor and don't use it.
Wait, then would it be D, the answer? If super.
Yes. So basically, like I said, we took in balance as a parameter. Maybe it's like $50,000. If we call it a default constructor, it'll probably assign balance to 0. So even though they started at $50,000, we said they have no money anymore, which is our mistake. So D is our correct answer, and the reason for that is we call super with balance, which will assign the balance correctly, and then it will assign my interest rate as well. So it makes a super call in the first line, checks that out. It correctly initializes the balance part. It deals with the interest rate in its own class because it can. And we're good to go. So really quick, running through this. The reason why this wouldn't work is because we're in the savings account, or we're in the savings account class. So you can't assign my balance equals balance. It's a private variable. So you cannot access it even as a child, you cannot access it. Remember, it has to be protected for it to be accessible by a child. So B is wrong. So get balance equals balance. Get balance actually isn't a variable. Get balance is a method call right here from the class. So you can't say this equals balance. This is a method call that returns a number, not a variable or anything. So this wouldn't work. And then my interest rate equals rate's fine, but it doesn't matter. That was already bad. This one doesn't work because we dropped our bank, and then this didn't work because we didn't have a constructor. All right, let's go to one last one. Okay, so
I have a question for that.
Yes.
Wait, should it have been rate equals my interest rate if his rate was so like?
We want to assign a variable for the class
Okay.
because it's called my interest rate, and then we want to get the variable we're passing in is the actual rate we want to assign.
Oh yeah.
So really quick, one last one. We're going to redefine the method withdraw in the checking account class. Okay? So there's a withdraw here. We're creating a withdraw. We're going to change it up. What is this an example of? The options are method overloading, method overriding, downcasting, dynamic binding, or static binding. Which almost done. Okay, I'm going to read it one more time. Redefining the withdraw method in checking account. The checking account class is an example of A, method overloading, B, method overriding, C, downcasting, D, dynamic binding, or E, static binding.
Would it be overriding? Method overriding.
You said overriding?
Yeah.
Perfect. Yep. So, we're almost done. So, a method overload is to change the parameters. So, withdraw, there's a parameter in here. But it's like changing the overloading would be in the same class having multiple withdrawals. So, like withdraw with like an int, withdraw with a double, withdraw with a string. You could do that. So that's an override. That's an overload. Overriding is in a subclass redefining a method from the superclass to be more useful in your context, which is what we're doing. Downcasting was where we did that assignment from here. We did the animal A equals new husky. That was where superclass is expected, a subclass is accepted kind of thing. Then we have dynamic binding, which is goes hand in hand with method overloading, where it has to at runtime decide what it needs to use. And finally, static binding, which is early binding, which just kind of happens normally. We don't really ever talk about it. So it basically says the whole code will run as usual, which isn't what happened. We're changing it up. All right. So, are there any questions I'm going to erase all this now. Are there any questions on the Space Needle thing so far? Is it going good?
So is it due next week?
Yeah, I want to say it's due next Friday.
And when it's due, will you show us like the most efficient way to write it?
Yeah, I have an answer already. Yes.
I think we could make if we set each part as a different class, we make them in separate files, or we make this.
Oh, for the Space Needle?
Yeah.
You can do it all in one file. I would just make 4 methods in your file and call them in the name. Everyone still has the instructions, and we're good on that, right?
Yeah.
Alright, with that, we're pretty much done for today.